Welcome. Today we're diving into the art of formulating a strong hypothesis, a crucial skill in research and problem solving. Whether you're a student, a scientist, or just curious about how discoveries are made, understanding hypotheses is essential. In this video, we'll break down the process step by step, making it approachable and practical. By the end, you'll know exactly how to craft a hypothesis that's clear, testable, and meaningful. Let's start by exploring what a hypothesis actually is and why it matters in any investigation. Hypothesis is more than just a guess. It's an educated prediction based on existing knowledge. It acts as a starting point for your research, guiding your questions and experiments. Think of it as a bridge between what you already know and what you want to discover. A strong hypothesis is specific, focused, and set the stage for testing. In the next scenes, we'll look at how to move from a general curiosity to a precise, actionable hypothesis. Every hypothesis begins with a good research question. This question should be clear, focused, and researchable. For example, instead of asking, "Why do plants grow?" you might ask, "Does the amount of sunlight affect the growth rate of tomato plants?" A well-defined question helps you narrow your focus and set the direction for your hypothesis. Let's see how to refine your curiosity into a solid research question. Before you can make a prediction, it's important to gather background information. This means reading up on what's already known about your topic. Look for previous studies, expert opinions, and reliable sources. This research will help you understand the context and avoid repeating past mistakes. It also ensures your hypothesis is grounded in facts, not just assumptions. Let's talk about how to efficiently gather and use background information. Strong hypothesis clearly identifies the variables involved. Variables are the factors you'll test or measure. There are two main types: independent variables, which you change, and dependent variables, which you observe. For example, if you're testing sunlight's effect on plants, sunlight is the independent variable and plant growth is the dependent variable. Pinpointing these variables helps you design a focused experiment. Hypothesis must be testable. This means you should be able to design an experiment or collect data to support or refute it. Avoid vague statements like "plants like sunlight." Instead say, "If tomato plants receive more sunlight, then they will grow taller." This structure allows you to measure results and draw conclusions. Testability is key to scientific progress. One of the simplest ways to write a hypothesis is to use the if-then structure. For example, if I water plants more often, then they will grow faster. This format makes your prediction clear and connects the independent and dependent variables. It's a straightforward way to communicate what you expect to happen and why. Specificity is crucial for a strong hypothesis. Instead of saying, "If plants get more water, they'll grow," specify how much water and what kind of growth you're measuring. For example, if tomato plants are watered with 200 ml daily, then their height will increase by 2 cm per week. The more precise you are, the easier it is to test and interpret your results. While it's important to be specific, your hypothesis should also be simple and focused. Avoid including too many variables or making it overly complicated. A straightforward hypothesis is easier to test and less likely to cause confusion. Stick to one main idea at a time for clarity and effectiveness. A strong hypothesis should make logical sense. Make sure your prediction follows from your background research and the variables you've chosen. If your hypothesis doesn't fit the facts or seems contradictory, revise it. Logical consistency ensures your experiment will yield meaningful results. In formulating your hypothesis, try to remain objective. Avoid letting personal beliefs or expectations influence your prediction. A biased hypothesis can lead to skewed results and unreliable conclusions. Stick to what the evidence suggests and be open to any outcome your experiment might reveal. It's good practice to think about alternative hypotheses, other possible explanations for your observations. This helps you design better experiments and prepares you for unexpected results. By considering different possibilities, you strengthen your research and avoid tunnel vision. Clarity is key when writing your hypothesis. Use simple, direct language that anyone can understand. Avoid jargon or overly technical terms unless necessary. A clear hypothesis is easier to communicate, test, and share with others. Once you've drafted your hypothesis, take time to review and revise it. Check for clarity, testability, and logical flow. Ask yourself if it's specific enough and whether it aligns with your research question. Don't be afraid to make changes. Refining your hypothesis is part of the process. Getting feedback from peers or mentors can help strengthen your hypothesis. Share your draft and ask for suggestions. Others might spot issues you missed or offer new perspectives. Collaboration is a valuable part of the scientific process. Your hypothesis should align with the overall goals of your research. Make sure it addresses the main question you want to answer and fits within the scope of your project. This alignment keeps your work focused and relevant. In many experiments, you'll also need a null hypothesis. This is a statement that there is no effect or relationship between variables. For example, sunlight has no effect on plant growth. Testing the null hypothesis helps you determine if your results are significant. Hypotheses can be directional or non-directional. A directional hypothesis predicts the specific direction of an effect, like plants will grow taller with more sunlight. A non-directional hypothesis simply states there will be an effect without specifying the direction. Choose the type that best fits your research question. Let's put it all together with a working example. Suppose you want to study the effect of fertilizer on plant growth. Your research question might be, does fertilizer increase the height of tomato plants? After background research, you identify your variables and write, if tomato plants receive fertilizer, then they will grow taller than those that do not. After formulating your hypothesis, the next step is to test it through experimentation or data collection. As you gather results, you may find the need to refine your hypothesis or adjust your approach. This iterative process is normal and helps you get closer to the truth. It's important to keep detailed records of your hypothesis, methods, and results. Good documentation allows you to track your progress, repeat experiments, and share your findings with others. It also helps you spot patterns and make improvements. Once you've tested your hypothesis, analyze the data you've collected. Look for patterns, trends, or unexpected outcomes. This analysis will help you determine whether your hypothesis was supported or refuted by the evidence. Based on your analysis, draw conclusions about your hypothesis. Was it supported by the data, or did the results suggest something different? Remember, even if your hypothesis wasn't supported, you've still learned something valuable. Every result adds to your understanding. Sharing your results is an important part of the scientific process. Write a clear report or presentation that explains your hypothesis, methods, results, and conclusions. This transparency allows others to learn from your work and build on your findings. Take time to reflect on the entire process, from forming your hypothesis to analyzing results. What went well? What could be improved next time? Reflection helps you grow as a researcher and prepares you for future investigations. Let's look at some common mistakes when formulating hypotheses. Avoid being too vague, making untestable predictions, or letting bias creep in. Also, don't ignore background research or skip defining your variables. Being aware of these pitfalls will help you create stronger hypotheses. If you're new to hypothesis writing, start simple. Practice with everyday questions and gradually tackle more complex topics. Don't be afraid to make mistakes. Each attempt helps you improve. Remember, clarity and testability are your best friends. Applying hypothesis formulation to real-life situations makes the process more relatable. For instance, you might hypothesize that drinking coffee in the morning improves alertness. Testing everyday ideas helps you see the value of strong hypotheses in action. The more you practice writing hypotheses, the better you'll get. Try formulating hypotheses for different subjects, science, business, or even personal goals. Each attempt builds your confidence and skill. Templates can help you structure your hypothesis. For example, if independent variable, then dependent variable. Using templates ensures you include all necessary elements and keeps your hypothesis organized. Reading published research can inspire your own hypotheses. Look at how experts phrase their predictions and structure their experiments. This exposure helps you learn best practices and avoid common mistakes. Curiosity drives great hypotheses. Always ask questions and look for patterns in the world around you. The more curious you are, the more ideas you'll generate for testing and exploration. Working with others can lead to stronger hypotheses. Discuss your ideas with classmates, colleagues, or mentors. Collaboration brings new perspectives and helps you spot weaknesses you might have missed. Technology can assist in hypothesis formulation. Use online databases to find background information or software tools to organize your variables and structure your hypothesis. Embracing technology makes the process more efficient. Be prepared for unexpected results. Sometimes your hypothesis won't be supported, and that's okay. Stay open-minded and ready to learn from every outcome. Flexibility is a hallmark of good research. Always consider ethics when formulating and testing hypotheses. Ensure your research respects privacy, consent, and safety. Ethical research builds trust and credibility in your findings. Not every hypothesis will be supported, and that's an important part of the process. Documenting failures helps you and others learn what doesn't work, saving time and resources in the future. When your hypothesis is supported by the data, take a moment to celebrate. Success is the result of careful planning, research, and testing. Recognize your achievements and use them as motivation for future projects. The world of research is always evolving. Stay up to date with new methods, tools, and discoveries. Continuous learning will help you formulate even stronger hypotheses over time. Hypothesis formulation isn't just for science. You can use these skills in business, education, and everyday problem solving. The ability to make predictions and test them is valuable in any field. Organization is key to successful hypothesis formulation and testing. Keep your notes, data, and drafts in order. This makes it easier to track your progress and share your work with others. Don't hesitate to ask for help if you're stuck. Teachers, mentors, and peers can offer guidance and support. Collaboration and seeking advice are important parts of the learning process. Looking at examples of strong and weak hypotheses can help you understand what works and what doesn't. Analyze sample hypotheses to see how they're structured and why they succeed or fail. Hypothesis formulation is a skill you can always improve. With each new project, aim to make your hypotheses clearer, more specific, and more testable. Growth comes with practice and reflection. Congratulations, you've learned how to formulate a strong hypothesis, from asking the right questions to testing and refining your ideas. Remember, a good hypothesis is clear, testable, and grounded in research. Keep practicing, stay curious, and apply these skills to all your future projects. Thanks for watching and happy researching.